Hello viewers, welcome to our YouTube channel Incredible Maths. In this video, we will solve some problems as in TNSET 2016 Mathematics in part 2. So the question number 21. So already 20 problems are solved in two parts. So this is a third video or part 3 of TNSET 2016 paper 2. The radius of convergence of the power series summation n plus 1 into z power n is. So we find the radius of convergence. So it is limit n tends to infinity an plus 1 by an. So this is equal to limit n tends to infinity. So this is our 1 by rho an plus 1, so replace n by n plus 1, so we get n plus 2 divided by n plus 1. So this is equal to limit n tends to infinity. So here we can take n into 1 plus 2 by n divided by n into 1 plus 1 by n. So we will get 1 by rho equal to 1, so therefore rho is equal to 1. So the radius of convergence is 1 for this problem. The second problem, it is 22. Let f be a non-constant entire function, which of the following is correct? So we are given a non-constant entire function. This is also based on result. So we will consider a non-constant entire function. F of z is equal to e power z. So this can be written as e power x plus iy and same e power x into, so this can be written as e power x into e power iy. So e power iy is cos y plus I sin y, and here real f of z is e power x cos y, and imaginary of f of z is e power x sin y. So these two are not equal. So given that real f of z is equal to imaginary f of z for every z in C. So this is wrong. And mod f of z is less than or equal to 1. So this is also wrong. And imaginary of f of z is less than 0. So this is also wrong. So therefore, so this one is D option is correct. F of z is never 0 for every z in C. So option D is correct. So next question. So this question also can be solved easily. F of x equal to x cube minus 2, then the root lies between. So we can substitute values for x. So the interval starts 1, so we will start with 1. F of 1 equal to 1 minus 2. So 1 cube 1. So this is less than 0. And you will find f of 2. So f of 2 is 8 minus 2. So this is greater than 0. Therefore root lies between 1 and 2. So the first two options are wrong. So we have this option C, 1 less than x less than 2 and 1 less than x less than 1.5. So this may also be correct. So you will check f of 1.5. So this can be written as f of 3 by 2. 3 by 2 cube is 27 by 2 cube is 8 minus 2. So this will be approximately some 3. Okay, so this is greater than 0. So therefore there is a change in sign between 1 and 1.5. The root lies in between 1 and 1.5, whereas the root does not lies in between 1.5 and 2 because both are greater than 0. Therefore root lies in between 1 and 1.5. Option C is wrong. So this is a direct question. The conditions on the matrix A for the Cholesky method applicable when A is symmetric. And question number 25, average formula truncated after second differences is equivalent to, so which one? So it's Bessel's truncated after third differences. Sorry. So question number 26, f g is continuous on the interval open interval a comma b, and g of x belongs to open interval a comma b for all x in a comma b, then G has a fixed point in closed interval a comma b, G has not a fixed point in closed So closed interval a comma b, g has a fixed point in closed interval a comma b, none of this. So for this we will consider a function satisfying the given conditions. So let us take g of x equal to x square. So x square and you will take x as x belongs to the open interval 1 comma 1. So suppose if we take any point in between 0 and 1, then g will not have a fixed point, so therefore option A is wrong. And g has not a fixed point in a comma b. Suppose if we take x equal to 0, g of 0 equal to 0, so here x is equal to 0 is fixed. So therefore this option is wrong, and g has a fixed point in the closed interval a comma b. So here x is equal to 0 is a fixed point, so this is true. So fixed by fixed point, so the definition is, so when can we say a point x as a fixed point? So if x is a fixed point of f of x, then f of x should satisfy this condition. F of x will be equal to x. So f of x will be equal to x. So it's a fixed point. So next, find the extremum of the function z equal to x cube y square into 6 minus x minus y. So this we have to solve. So the extremum occurs when the first derivative is equal to 0. So in the case of single variable, so here z depends on two variable. So z is function of two variable. So therefore we will find the first derivative of z with respect to x, that is zx equal to 0 and zy equal to 0. So we will find x and y. So when zx equal to 0, so this can be written as, so we will expand this one, 6x cube y square minus x power 4 y square minus x cube y cube. Now zx equals equal to 0. So differentiation, partial differentiation with respect to x will give you 18x square y square minus 4x cube y square minus 3x square y cube so equal to 0. So equal to 0. So now you can take x square y square. So we will get 18 minus 4x minus 3y equal to 0. So this is equal to 0 and this also will be equal to 0. So from this we will get 4x plus 3y equal to 18. And here z equal to 0, definition, partial differentiation with respect to y. So you get 12x cube y minus 2x power 4y minus 3x cube y square equal to 0. So here we can take x cube y, so common factor. So 12 minus 2x minus 3y equal to 0. So here we will get 2x plus 3y equal to 12. So now we will solve these two equations to get x and y. So the second equation, so change sign, so these two will cancel. So 2x equal to 6. So this implies x is equal to 3. X is equal to 3. So this is the only correct option. So all other options are wrong. So we will check whether x equal to 3 is correct. 3, 2 is correct. So from this we find y. So this implies, substitute in second equation, 2 into x is 3 plus 3y equal to 12. So 3y equal to 12 minus 6, 9. So 12 minus 6, 6. So this implies our y, so y is 2, therefore the option D is correct. So next problem number 28, find the extremals of the function. So this is based on calculus of variation, integral x0 to x1 y dash square by x cube dx equal to 0. So the extremals can be find out for the functional based on the Euler-Lagrange equation. So what is Euler-Lagrange equation? So fy minus d by dx of fy dash equal to 0. So what is f? F is a function of x, y and y dash. So fy is partial differentiation of f with respect to y, and fy dash is partial differentiation of f with respect to y dash. So here fy is 0, so minus d by dx of, so fy dash is 2y dash by x cube equal to 0. So differentiation of this function is equal to 0. So therefore this function will be equal to some constant. So 2y dash by x cube equal to some constant c. So now y dash equal to c by 2 x cube. So now we integrate this one. So y is equal to c by 2 x power 4 by 4 plus some other constant c1. So this can be written as some k1 and so this one c by 4 into 8, this can be written as c1 or k1, and this can be written as some k2. So therefore based on this we can say option 3C is correct. So other options are wrong. So next one, Rayleigh-Ritz method. So it's a direct question. It's used to solve boundary value problems. So next problem. So find the extremals of the functional I of y of x comma z of x equal to integral 0 to pi by 2 y dash square plus z square plus 2 yz d is yz dx satisfying the conditions y of 0 equal to 0, y of pi by 2 equal to 1, z of 0 is equal to 0, z of pi by 2 equal to minus 1. So therefore, so here also we will be having the Euler-Lagrange equations. So without solving or without solving this problem directly, so we will check the options answer based on the given options. So the y has to satisfy, y and z has to satisfy these 4 conditions. So we will see whether y of 0 equal to 0. So sin 0 0, so all satisfies. So this condition is satisfied by all options. Y of pi by 2 equal to 1, it is sin pi by 2. Okay, so we know sin 0 is 0, sin pi by 2 equal to 1. Okay, so these two things we need to know. So y of pi by 2 is equal to 1, sin pi by 2 it's 1, and here it is minus 1, so therefore this is wrong. So this will also be 1, so it suits this one, and here we get y equal to minus 1, so option B and C are wrong. So that z of 0 equal to 0, so sin 0 0, and here sin 0 is also 0, and z of pi by 2 equal to minus 1. Z of pi by 2 equal to minus 1. So sin pi by 2, so we will get is plus 1. So therefore, so this is wrong. So here we get minus. So this is the option. So the option C satisfies all the conditions. So therefore this is the correct option. So if you like the content of these videos, kindly like and share with your friends. Also subscribe our channel. Thank you.